So, hello and welcome to my indie game devlog. And so, first of all, Happy New Year. I know I'm like a month late, but hopefully 2020 has been really good to you guys. So, yeah, if you haven't watched my last video, that's a gameplay video, and it has changed a lot since then. And I'll leave that link in the description, but let me show you what I have so far. So as you can see from the gameplay, we have a lot of nice effects going on now, and this is actually the change logs that has been done since the last video. And I've added a trail renderer. I've added an effect for whether it's wrong or correct. Like when it's correct, you can see the purple transparent arrow would like just come up from the square, and then if it's wrong, that won't be there. So yeah, and then the score. Now, when you cut it correctly, first of all, it would give this effect, right? And then once you see the effect, you can see the score go up. So that's already according to the cut calculation. And then next thing is the text rendering. In my last devlog, not the gameplay one, the last one before that, you can see that the text rendering still has a border, like a black border beside it, and now that's already fixed because I changed the shader. And then I've added a line intersection algorithm. That is for you can see like when we cut it, the sprites get cut into two, and the cut direction and position and everything is calculated on the fly, and that is according to where you cut the sprite. So it would just, it would calculate like two intersection points, and then get the midpoint, and then get the normal, and then pass it into the shader, and then the shader would do all the rendering, like cutting stuff. So yeah, let me just explain how I did the trail renderer. So the trail renderer is, you can see over here, this function would pass a point into the trail renderer, and then the trail renderer would calculate like 2 points on the left and the right of that, according to where you slash, basically. And then using all the lines of each point, it would calculate the triangle. So it renders like a triangle strip, and the result is a nice trail rendering. Actually, let me just show the code as well. Trail renderer. Um, yeah, it's over here. See, this is where the magic happens. So what it does is it calculates the direction from point now to other point, and then just like this, and then it gets the direction. And then once that's done, we take the up vector, and then we dot product it with this direction to get the degree, like the angle, right? And then using this angle, we rotate the left and the right direction. Wait, hold on. Yeah, it's over here, see? We rotate the left and the right direction, and then yeah, we get 2 points, and then we just get a line from there according to all the points and stuff. We draw a triangle strip. So by doing that, it would render the trail nicely, basically. So yeah, that's how the trail renderer works. And the correct or wrong cut effect. So that one is over here. And the way I'm doing that is I basically wrote a shader that would just do additive blending. Yeah, here it is. So this is how I'm blending the arrow thing, and this is how I'm rendering the arrow thing. And then the arrow thing is basically just a sprite, and I've discarded all the other pixels except for the arrow ones, and then it's already like purple in color. So I just have to like blend it additively using alpha blending, and then that's it. Just it would just render that thing, and then it would just keep going up. It would just keep growing, and when it grows, it will also like reduce the alpha value, and when it grows past a certain point, it would just not render it anymore. And then the next time when when we cut it, when we cut another square or whatever, and when the effect is needed, it would just reuse the effect sprite basically. So yeah, that's how the I've achieved the effect. Now the score is according to the cut direction. Yeah, in the game class itself, I have like previous touch position and current touch position, and then just calculate the vector from the old one to the new one, get the direction, and then dot product it with the up direction of the square that we're slicing. And then if it's like in a certain threshold, that means we're cutting in the right direction. So just add the score and then show the effect and stuff. And then yeah, so I've talked about this. And yeah, the line intersection algorithm, that's like the sprite is made of like two triangles. So I just took like the lines that are on the border, like the 4 lines that are on the border, and then according to the cut direction and the cut position, it would find out 2 points which intersect, and according to those 2 points, we can find the midpoint and then find the normal. Yeah, and then we pass all that to the shader, and the normal is in texture coordinate space, and we pass it to the shader, and then the shader would do like a dot calculation to see whether it's behind or in front of the normal. If it's in front of the normal, then it would render it, otherwise it wouldn't render it. So actually the sprite that we're cutting is not rendered anymore, and then we add 2 more sprites. Those 2 sprites form the cut pieces, the left and the right cut pieces. So it's actually 2 objects, 2 sprites, and I'm just passing the normal and the negative normal. So the 2 sprites will be cut at the exact position, but one will render on one side and one will render on the other. I convert the texture coordinate normal back to world space, and then it would move it based on that basically. So yeah, it's pretty complicated, but as you can see, the effect is really nice, and I wanted to implement it so bad, and I did. So yeah. So in my gameplay video, there was a comment by Ballistic Boy Plays, and it was about power-ups, and he said that make a power-up to like play the game in slow-mo, or play the current track in slow-mo, and I actually liked his idea, and I plan on implementing it. So thanks for that. Thank you for the suggestion. I'll see you guys next time. Peace.